All right, here is a lesson on curve fitting with quadratic models. So this is the parent function of f of x equals x squared graphed out, and then the table of values. For you to have a quadratic function, you need to have two things. Number one, equally spaced x values, and a constant second difference. So here's an example. Determine whether the data could represent a quadratic function. So first we look at the x values right here. Notice that all of those x values going from one order pair to the next is increasing, so change of x of +2. Then we look at the y values. So we need to first find the first difference. So we're going from 12 down to 10, so we're subtracting 2. Then we're going from 10 to 9, subtracting 1. Then from 9 to 0, or 9 to 9, we're getting 0. And then from 9 to 10, we're getting +1. So that's the first difference. Now we need to go to the second difference. So we go from -2 to -1, we're increasing by 1. From -1 to 0, we're increasing by 1. And then from 0 to 1, we're increasing by 1. So this is considered a quadratic function because it has the same common second difference. The common second difference is increasing by a +1. So yes, it's a quadratic function. Example 2. We're going to first look at the x values. All of the x values are equally spaced. They all are increasing by +1. Then we go to the y's. From 1 to 2, we're increasing by 1. From 2 to 4, we're increasing by 2. From 4 to 8, we're increasing by 4. And then 8 to 16, we're increasing by 8. So that's the first difference. Then we go to the second difference. So we increase from 1 to 2 for +1. And then from 2 to 4, we're increasing by +2. And then from 4 to 8, we're increasing by +4. The second difference is not the same throughout. So this is not considered a quadratic function because it doesn't have a common second difference.